Hi Year 11s, I hope you're having a lovely half term. Just a reminder here on this first slide about the upcoming PPE exams that you've got. So a reminder that in science, this is all the content that you've been covering with your Year 11 science teachers since September. So you can see the second week back, we've got biology paper 2, then we've got on Wednesday the 8th of March chemistry paper 2, and then the Friday of that week we have got physics. So I'm going to be talking you through the chromatography required practical today, which unfortunately we haven't had a chance yet to cover in class. And so therefore that's why this homework is really important. So chromatography, you should recognise this picture on the board. You first did chromatography when you were in Year 7, and chromatography is basically used to separate different mixtures, and it gives us information in order to help to identify substances. So I'm sure you probably remember seeing this setup. When you're in lower school, we normally do this testing the inks which are in different coloured pens. Some of you may even have done a chromatography experiment for your science fair projects. For example, you can do chromatography with Skittles or Smarties. So this here is a picture of a diagram from an exam paper, because I think it's really important you get used to what this looks like in the exam. So this, I'm going to talk you through how we set up the required practical. So as you saw in the previous slide, you have a beaker and then you have your special absorbent chromatography paper. So what you do before you put the chromatography paper into your solvent, you would draw a line a couple of centimetres from the bottom, which we call the start line, and you do this in pencil. This is a really common exam question. The reason why we do it in pencil, the start line, is if we did it in pen, then what would happen when you put the chromatography paper into the solvent is that the pen line would also run. So that's really important. We always do the start line with pencil so that when you put it in the solvent, the pencil doesn't run. So you do your start line, you put different substances in which you're going to be testing, and then you place your chromatography paper into the solvent. Now the solvent which we would have used with you when you're in Year 7 is water, but just be aware that there's lots of different solvents that you can use, and some substances will be insoluble in water, so you might have to use a different solvent instead. So the other common exam questions, so they tend to ask, they give you a picture like this or similar to this, and they'll say describe the errors that you can see in the equipment setup. So this picture, there aren't any errors, but another one common question would be if the solvent line was above the start line. Now this is really problematic. You can see in this picture the solvent is very clearly below the start line. If the solvent was above the start line, what would happen is the sample that you have on your start line would wash off the paper and it would mix with the solvent, and then you wouldn't have the colours moving up the page. In this case, you can see that there's also a lid added to the experiment. So this would be to prevent evaporation of the solvent. And sometimes you will get asked in terms of chromatography what is meant by the mobile phase and the stationary phase. So the stationary phase is the thing which is not moving. So in this case, it's the chromatography paper. And then the mobile phase is the thing which is mobile, the thing which is moving. So this would be the solvent. And as I said, when you have done this before in school, the solvent that we use is water. So another common question in terms of the exam is they get you to interpret chromatograms. So again, I've pulled this from a previous exam question, and the question would be along the lines of what colours make up the black ink? So looking at this chromatogram, you can see they've labelled the start line, which I've already talked about, should be done in pencil, and then something at the top of the diagram, the solvent front, which I'll talk you through in a minute. But what you basically do is you look, in this case, we're looking at what colours make up the black ink. So what you do is you can see there's 3 spots if you look at the black ink and you go above it, there's 3 spots. So this tells you that the black ink is made up of 3 different colours. And what you do is you go to the first spot above the black ink line, and then you just go across the page. So you go to the left and you can see that it has the same spot as the red colour. So this means that the black ink contains red. If you then go up to the second spot on the black ink, and again you do the same thing, you read across the page to the left, you can see that there is blue also present in black ink. And then you can see the top spot that it is a colour which hasn't been tested, so it doesn't match with blue, green or red. So in the exam, if this was a 2-mark question, which colours make up black ink, you would say red and blue. There's another question you could get asked in terms of interpreting chromatograms. They could ask you which colour is least soluble in the solvent. So the colours which are most soluble will move the furthest up the page, and then the colours which are least soluble will move the least distance from the start line. So in this example here, the red colour is the least soluble because it has moved the least distance. Okay, so that really isn't new from what you've done in year 7. This next bit is new. So part of the GCSE curriculum is you need to calculate what we call the RF values. And basically what the RF value is, it's just the ratio of the distance moved by the compound to the distance moved by the solvent. And this is the equation that we're going to use to calculate it. So the RF value is equal to the distance moved by the substance divided by the distance moved by the solvent. And this can come in different forms in the exam, so I've just pulled a couple of different ones to show you. So for example, this question, in a different experiment, a student recorded these results. So distance moved by dye G is 60 millimeters, distance moved by the solvent is 80 millimeters, and they are asking you to calculate the RF value of dye G. And they've given you the calculation, so literally all you would need to do is substitute in the numbers. So the distance moved by dye G was 60, the distance moved by the solvent was 80, so you'd plug that into your calculator, 60 divided by 80, and that would give you an RF value of 0.75. So very straightforward, you're always allowed your calculator. These should be easy marks for you to get. So we've got another question here. So a student makes measurements for spot C. The table shows the results. Calculate the RF value for spot C. Give your answer to 2 significant figures. So this is where they will often use some math skills, So give your answer to 2 significant figures. This would actually be a 3-mark question. So what we would need to do is the distance moved by spot C, which is 7 millimeters, and we would divide that by the distance moved by the solvent, which is 39 millimeters, and that would give us an answer of 0.17948. And they are asking us to give our answer to 2 significant figures. So what you need to do is you need to look at what the third figure is. In this case so it's 0.179. So because the third figure is above 5, we would round up our answer. So our answer in the exam would be 0.18 to 2 significant figures. So those are where they have given you values. They could also ask you for you to pull out the measurements from the exam question. So here, again, another snapshot from a different exam paper. So here they've given you a diagram, you've got the start line, you've got the solvent front, and they want you to calculate the RF value of drug G. So what you would need to do is you'd need to use a ruler, and the first thing you would do is you would measure the distance between the start line and the solvent front. And it doesn't matter if you record that in millimeters or centimeters, as long as when you then do the distance moved by the substance that you use the same unit. So if you used millimeters for the start line to the solvent front, make sure you use millimeters when you do your next reading. So what you would then do once you've recorded that, you would then use your ruler to measure between the start line, and this bit's really important, it needs to be from the centre of the spot, and in this case it's the centre of the G spot. So what you would do is you would record that measurement again in either centimetres or millimetres, whatever you used before, and then you would do your, remember it's the distance moved by the substance divided by the distance moved by the solvent. So what I would like you to do, please, is you're going to pause the video here. You have got a Seneca assignment set by your class teacher for you to work through, and then also you were given some chromatography exam questions in your exam question pack. And once you have done both of those tasks, you can then press play, and the second part of the video is all to do with crude oil and alkanes. So welcome back, Year 11. Second part of the video, we're going to be looking at crude oil. So crude oil is one of the 3 fossil fuels. Okay, so we've got coal, natural gas and crude oil. And as you should know, fossil fuels are all finite resources, which means that we are using them up at a quicker rate than which they can be replaced. And you're expected to know how crude oil is formed. So you will have done this in the atmosphere topic with your teachers in class, but how crude oil is formed is plankton was buried in mud and was formed over millions of years, and that formed crude oil, which is a fossil fuel. So crude oil, as you can see from the diagram, is not a particularly useful substance. Okay, so it goes through a process called fractional distillation to separate out to make crude oil more useful. So for example, petrol and diesel come from crude oil. The crude oil that you get out the ground, you have to go through this process of fractional distillation in order to get petrol and diesel, which are what we call useful fractions. So crude oil is made up mostly of what we call hydrocarbons. So hydrocarbons, break the word down, hydro made up of hydrogen, carbon made up of carbon. So hydrocarbons are made up of hydrogen and they're made up of carbon. And there's 2 different types of hydrocarbons, and we're going to be learning about both of them today. So they are called alkanes and alkenes, and we're going to start off by looking at alkanes. So this slide here is talking through the homologous series of alkanes, and the general formula for the homologous series of alkanes is CnH2n+2. And what you're expected to know for the exam is you're expected to be able to name and draw the first 4 alkanes. So methane contains, as we can see from the diagram, it contains 1 carbon. And if we substitute the number 1 into the letter N, so C would be 1, therefore the number of hydrogens would be 2 times 1, so 2 plus 2. So methane has 4 hydrogens. If you have the eth prefix, that means 2. So ethane has 2 carbons, and again if we substitute 2 to the letter N to calculate the number of hydrogens, we would do 2 times by 2 is 4 plus 2 is 6, so therefore the formula for ethane is C2H6. Propane is when you have 3 carbons, so the prop prefix means 3, and then the bute prefix means 4. So this is just to show you what it could look like in the exam. So alkanes are hydrocarbons. Give the name of the alkane molecule that has 3 carbon atoms. So 3 carbon atoms, we know that that's the prefix prop. So therefore the alkane name is going to be propane. This is a different style of question. So again, this time it says the image below represents an alkane. What is the formula of the alkane in the image above? So the black dots are representing the carbon. So we can see that there's 3 carbons. So sorry, the bell, you can see that there's 3 carbons, and then the white dots are representing the hydrogen, and there are 8. So what we would write down for this question, so the formula for the alkane is C3H8. So as mentioned before, crude oil itself is not particularly useful. It goes through this process called fractional distillation that you'll learn about in class after half term. And basically fractional distillation separates out different fractions of hydrocarbons based on their length. And so you end up with some really short chain hydrocarbons and you end up with some long chain hydrocarbons. Now typically the longer chain hydrocarbons are not as useful as the shorter chain hydrocarbons. So what happens is this process called cracking. So what happens is you take a fraction from your fractional distillation. So as I said, you take one of the long chain molecules, and what you do is you heat it up to vaporize it. So you're turning it into a gas. And then with cracking, there's 2 different things that you could do. So there's something called catalytic cracking. Clue is in the name, catalytic cracking. You pass your vaporized fraction over a catalyst. Or there's something called thermal cracking, and in thermal cracking it's the same principle. So you vaporize your hydrocarbon fraction, you mix it with steam, and then you heat it to a very high temperature. So it doesn't matter which one you do, catalytic or thermal, but basically what happens is our long chain hydrocarbon is cracked, it is split into a short chain hydrocarbon, an alkane, and also you get the production of something called an alkene. Now if you look at the diagram, you can see the top diagram on the right hand side is showing an alkene, and the bottom diagram on the right hand side is showing an alkane. Hopefully you can notice that the difference between the 2 is the one at the top, there is a double bond between the carbon denoted by the 2 lines between the C's, as opposed to alkanes which all have single carbon-carbon bonds. Okay, so alkenes have a double carbon-carbon bond, whereas alkanes only have single carbon-carbon bonds. And what you may have to do in the exam is complete an equation for cracking. So as you can see, it says decane, which is C10H22, is cracked to produce 2 products. Complete the equation for this reaction. So they've given you decane on the left-hand side, and then they've given you ethene as a product on the right-hand side. It's very straightforward what you need to do to work out what the other product is. You just take the right hand side away from the left hand side. So you can see we started with 10 carbons. One of our products contains 2 carbons, therefore our other product must contain 8 carbons. Same principle with the hydrogens. Our reactant, we started with 22 hydrogens. Our product only has 4 hydrogens, therefore we must know that the number of hydrogens in our other product is 18. So therefore we would write that as C8H18. So we can see that that is an alkane because it follows the general formula CnH2n plus 2. Just another one, so you can see that it's a similar style question. So again, this is actually a decane again, but you can see it's different products. So again, to work out what are the formula of our second product, to work out the carbons, you would do 10 take away 7, so we've got 3 carbons. To work out the hydrogens, you do 22 take away 16, which would give you C3H8 as our formula. okay, which again is an alkane because it follows the formula CnH2n+2, and in this case we can actually name it. We know if it's got 3 carbons, it's got the prefix prop, so this is propane. Final thing for us to cover is how do we test to see if we have an alkane or an alkene. So we use a chemical called bromine water. And the picture on the left is showing that if you add bromine water to an alkane, there is no change to the bromine water. So bromine water is orange in colour. But what happens if you add bromine water to an alkene? So remember, that's one that has a carbon-carbon double bond. What happens is the bromine water goes from orange to colourless. So just to show you, this would be worth 2 marks in the exam. So C2H4 is an alkene. What is the test for alkenes? Give the result of the test of an alkene is present. So the test, I'm just going to show you the mark scheme, what you'd have to put. So you would need to say that it's bromine water that we would use, and the result, well, it goes from orange to colourless. So what I'd like you to do here is to stop the video, and you should have a Seneca assignment from your class teacher all on alkanes, and then I would like you to do the alkane exam question given in the question pack, and I would like you to then bring in your exam question pack to your first lesson back after half term. I hope you have a really lovely rest of your break, and I will see you when you're back in school next week. Bye.